Here we have the robot arm set up. We have my circuit, the schematic, and the actual arm and PCB. I'm going to go ahead and explain a few things about the circuit. Any long wires that you see are going from subsystem to subsystem, and all the flat wires go between inter-subsystem, like in between, so like the counter is all flat and connected to itself. And I'm going to go system by system. Up here we have the counter. We have 3 4-bit counters. All the whites, this is for the whole thing, all the white cords are for power and ground of each chip. They're used for nothing else anywhere. In the counter, we have connections, just a few. We have the up being green and the down being yellow, and that's really it. There's not too much going on in the counter. Then down here we have the syncing and edge detection for phase and quadrature. All the blue is for phase, and that's because we're syncing and edge detecting it. And then all the yellow on this side is just for quadrature, and it's just edge detecting. And we see that, or just syncing, sorry, just syncing. And we see that, and this green wire is going to the motor, going to quadrature, and this one is for phase, this yellow one, and it's coming from the motor over here. Alright, and then this is an OR gate used for logic a bit later, but then this whole row here and these 3 chips are for the FSM. We have the reset button up here, the action button right below that, and we see that they are debounced, and then the action button is edge detected and synchronized over here with this system up here, and it's all yellow. The reset button isn't synchronized or edge detected, but it doesn't need to be, because as long as it becomes pressed, we send a 1 to the system and it resets. So that's okay. The action button does need to, and that's why it gets set over here. Then we have the FSM. The FSM is comprised of all these chips over here and here. It is color-coded. We have green is the 2nd bit of the state machine for the state encoding. Yellow is the 1st bit, so and this is all the flat. And black is for the 0th bit of the FSM, and that's everything you see here. These 3 lights indicate the state number. That we have the 0th bit, the 1st bit, and the 2nd bit, and then this light is actually going to indicate the equal input from the comparator, but that comes later. We have the clock here. This clock is running at 5.29 kilohertz, which is why it appears to be on all the time, but it's not. This is going to be for any internal logic, and already explained the edge detection and synchronization happening up here. Then we move over here. On this side we have our register files, our comparators, then the clock for the motor, which is only running at 481 hertz. And then we have just a logic chip for motor logic, and that'll be explained in the schematic and report. So that's the whole system here. You can see this is a very far out schematic of the entire circuit with the clocks and their associated values mentioned. It's not laid out in the same way on this as it is down there, but with positioning, but the exact schematic that's up here was translated down here in terms of what is on the board. Alright, so let's get to testing. So for the testing, we have the motor on. We have this here to move it, and the idea is that what we do here and press down, when we press the action button, it'll record the locations and then play back. So let's see. So if we press the reset button, now all the states were at 0, but reset it. Now we have state 0, 0, 0, which is going, now we'll look back at our schematic up here. So state 0, 0, 0 is right over here. We see that's our first recording state. And so right now it's recording. And when I press the action button, it'll record that location, but I'm not going to press that yet. So we're going to move it a little bit. And we see it's moving counterclockwise. And now we moved it, and I'll press the action button. So now we see that we're in state 1. That's because the 0th bit is 1, and the other 2 are 0. The equal input doesn't actually make a difference. This is the equal input. We're not paying attention to that now because, as we can see by the FSM, it won't make a difference at all until we are in states, until we're in the play states, which are states 4 through 7. So now we're going to record the second location. So that also moved counterclockwise. So we're going to record that. And now we see we're in, let's see. Oh, now we're in state 2. And we're going to move it. And I'm going to record, and that went clockwise. Now we're in state 3, and this is the final recording state. Now I'm going to go counterclockwise again. And record it, and now this will start playback. So now we're in state 3, moving to state 4, which starts the playback loop. And we see that now we're switching through the states, so we're in. So now the second bit is lit, so we're at 1, and then these are switching. So we're going between 4, 5, 6, 7, 4, 5, 6, 7, 4, 5, 6, 7, and it keeps switching. And we see the motion as was chosen, which is just moving back and forth. We move counterclockwise, counterclockwise, clockwise, counterclockwise. And we see that. So this is working. One other thing to test is that the action button has no effect in these states, and we see that because at this they're not. So we have E being what's moving it from state to state, and it's a condition on E and R only. So when I press the action button, shouldn't be any changes, and we see no changes to the system. It continues going through no matter how many times I press it. That's system. Let's see. We can give it one more test, and here, let's see. So I'm going to reset it now, and now this is going to stop it. And so now we're back in state 0, 0, which is exactly what we see over here. So we move from these states, the play states, right back to state 1. So now in state 1, if I move the motor, record a state, now we're in state 1, and then say I want to restart. If I press reset, you see that it goes back to 0, 0. If I were to record a state, record 2, reset, it goes back to 0, 0. Record a state, record a state, record a state, go 0, and it goes to 0. So we see that all the reset conditions work. We saw that the action button progresses it, and those are the only inputs. So those are the inputs, and we see that the motor isn't moving in these cases. So the input logic and output logic of the FSM works for the first 4 states, and for the second 4 states we saw the motor was moving, and we saw that whenever the equal input was 1, it progressed, and when it was 0, it stayed. And we also saw that the reset button resets it. So that's the input, and we saw the motor was moving, so that's the output was working for the FSM. So we'll give it one more try here. So we'll reset it. So we're moving counterclockwise. Set, change to state 1, or state 2 really, according to the state encoding. Then we're going clockwise, state 2, and now I'm going to make it go counterclockwise, but I'm going to make it go a little longer, and we'll see that chiming change. State 3, and now I'm going to make it go clockwise. I'm going to make it go just a little bit. Alright, so now when I press the action button again, it's going to record the 4th location and start the switching. So we see that whenever the equal input is 1, we switch states. You see that this input, which is the equal input, corresponds to the switching of these lights from 4 to 5 to 6 to 7, and we see that the motion is what we said. Here, I'll show the lights. So we have the long and then a short, and that's following the motion that we recorded. Then, so that's showing it works, and now we'll press the reset button again, and that should zero out, go back to state 0. Alright, so that's all the inputs, all the outputs. We see that all parts of the circuit work. We have the edge detection, we have everything from getting the inputs into the format we want with edge detection and syncing, to the 12-bit counter recording locations, to the comparator, which gets input from the FSM and which gets inputs from the action and the equal and reset buttons. We see that it's writing and reading as supposed to happen. The comparator sends the output to, so the comparator sends the output from the equal input to the FSM, and it sends the output from the greater than output to the motor, which is, before it gets to the motor though, it's ANDed with S2 so that it's not producing a 1 in the direction, except when we're in those 4 playback states. Okay, we're going to do one more test here. I'm going to reset. We're starting at state 0. Record it short, going clockwise. Record that location, now we're in state 1. Short, going counterclockwise. State 2. Short, going clockwise. Now we're going state 3, and then I'm going to make it go long counterclockwise. So now we should be able to see short, 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 long. So it moves to the original location, short, 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 long. It's going to move back, and short, 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 long, and then moves back, and it's just going to keep repeating that. And we see that that's the same motion that we recorded in positions. We see that while the motor's rotating, we see that we're in the right state. So we're in state 4, 5, 6, 7, 4, 5, 6, 7. It's a little hard to see the LEDs, but 4, 5, 6, 7. And that's the motion. So this indeed works.